All right, let's go ahead and get started. I do want to welcome you to this worksheet. This is the second half of stoichiometric calculations. These problems are intended for pre-AP students, so if you're one of those, then you're in the right place. Let's look at number 7. It says calculate the number of grams of nitrogen gas required to make 1.22 liters of ammonia at STP. So we're going to need to learn, first of all, what we mean by this term STP. What is STP? Well, STP is an abbreviation for standard temperature and pressure. And essentially what it means is that temperature is defined as 0 degrees Celsius and pressure is 1 atmosphere. It's a way of measuring the pressure of a gas. So when the temperature is 0 degrees Celsius and the pressure is 1 atmosphere, something very, very peculiar happens to the volume of a gas. At STP, at standard temperature and pressure, the volume of any gas, is this number. It's 22.4 liters. Now we're going to need to remember that number because it's going to help us through these problem sets. So let's take a look at this problem entirely now. It says calculate the number of grams of nitrogen gas. That's what I'm looking for, required to make 1.22 liters of ammonia. That's the number I've been given, so I'm going to circle that. Now the next thing I'm going to need to do is I'm going to need to correctly balance this equation or this reaction. And this will do it. 1, 3, 2, right? We'll balance this reaction. So 1 mole of nitrogen gas reacting with 3 moles of hydrogen gas produce 2 moles of ammonia. All three, by the way, are gases. Both nitrogen, hydrogen gas, and ammonia are gases at standard temperature and pressure. So we're going to keep that in mind. Where do we start? Well, we start with what we've circled. We've got 1.22 liters of ammonia. So let me start there. So 1.22 liters of NH3. I'm going to put that over 1 to hold the place. Now, I've told you that if you have anything other than moles, you've got to get to moles as soon as possible by whatever means necessary. So if I've got liters of NH3 here, I'm going to want liters of NH3 down here. So that's what I'll put down here. And I'm going to put moles up here, moles of ammonia on top. Now what I'm going to do is ask myself, do I know this relationship? What is the relationship between moles of ammonia and liters of ammonia? Well, remember that I'm at STP. And at STP, 1 mole of any gas, not just ammonia, but any gas, is this, 22.4 liters. So I'll put a 22.4 on bottom. I'm going to cancel this unit with this unit, and I'm left with moles of ammonia, just like that. Now what I'm going to do is I'm going to do what we call a mole-to-mole bridge. Moles of ammonia on top, upper left, so I'm going to put moles of ammonia on the lower right, just like that. Moles of NH3 down here. On top, I'm going to bridge to moles of nitrogen gas, or moles of N2. Well, what is that relationship? What's the relationship between N2 and NH2? Here it is. 1 mole of N2 produces 2 moles of NH3, right? 1 mole of N2 produces 2 moles of NH3. So I'll make this a 1 to 2 mole-to-mole ratio. I'll cancel this unit with this unit, and I'm going to be left with moles of nitrogen gas. Not quite done yet because I want to go to grams of nitrogen gas. That's what I've been asked. That's what I underlined. So I'm going to put another multiplication sign right there. If this on top was moles of N2, I'm going to put moles of N2 on bottom. And on top, I'm going to write grams of N2, just like that. How do I determine the number of grams per mole? Go to the periodic table. If it's just N, if it's just nitrogen, it's 14.1, but it's not just N, it's N2. So I'll double that. That becomes 28.02 grams per mole. Now this and this are going to cancel, and I'm going to be left with grams of N2. That's exactly what I want. I'm going to multiply the numbers on top, hit the equal button, divide by 22.4, hit the equal button again, and then divide again by 2 and hit the equal button again. Here's what I get on my calculator. Check me on this, 0.76304, but let's do that to the correct number of significant digits. Let's see, 3, 3, 4. I can have 3 significant digits, so I'm going to say 0.763, and the unit is grams of N2. Let me make that a little neater. Grams of nitrogen gas. And I am done with this problem, okay? Let's go to number 8. Number 8 says, how many grams of zinc are required to react with 125 milliliters of a 3.00, and then there's this capital M hydrochloric acid. So let's talk a little bit about what that capital M means. That capital M that I'm referring to here means molarity. So molarity is a unit of concentration, all right? And what we mean by molarity is moles of solute divided by liters of solvent. So when we have a 3.00 capital M hydrochloric acid solution, what we're saying is we've got 3.00 moles per liter of hydrochloric acid, right? That's what molarity means. So how do we approach this problem? Here's what we're going to do. We're going to circle the numbers that we've been given. Now this time, this is the first time we've been given two numbers. I'll circle both of them just like that. And I'm being asked for the number of grams of zinc, right? So I'm going to need a balanced reaction now. So on the balanced reaction, I have 1, 2, 1, 1. Check me on that. I'm pretty sure that is correct. So now what we're going to do with those numbers is as follows. I'm going to start the problem. I'm going to begin the problem by, in my head, converting milliliters to liters, right? I'm going to convert from 125 milliliters to liters by moving the decimal place over 1, 2, 3 places to the left. So let me start there. I'm going to say 0.125 liters, and that, of course, is HCl, right? Now look what I'm going to do. I'm going to multiply that number by the molarity. But instead of writing capital M, I'm going to write this. I'm going to write 3.00. What did I say molarity was? Moles per liter, right? That's what we mean by molarity. 3.00 capital M means 3.00 moles of HCl per liter. Now, why did I do that? I did that because of the fact that now liters of HCl and liters of HCl are going to cancel, and look what I'm left with, moles of hydrochloric acid. Remember that I said that if you're in any unit other than moles, you have to get to moles immediately. I'm there now, right? So I can kind of proceed with the problem at this point, right? So now what we're going to do is this. Whatever unit's in the upper left goes in the lower right. So I'm going to write moles of HCl on the lower right. On top, what I'm going to do is a mole-to-mole bridge. So I need to get to zinc because I'm being asked about zinc. So I'm going to write moles of zinc here. Now, what is that relationship? What's the relationship between zinc and hydrochloric acid? Well, 1 mole of zinc requires 2 moles of hydrochloric acid. 1 mole of zinc requires 2 moles. Let me change the color. 1 mole of zinc requires 2 moles of hydrochloric acid, just like that, okay? Now what I'm going to do is I'm going to cancel this unit with this unit, and I'm going to be left with moles of zinc. I'm not quite done yet. I'm going to erase this because I'm going to need that room, and I'm going to need to do one more step, right? And the step that I'm going to do is whatever unit's in the upper left goes in the lower right. We've got moles of zinc in the lower right now, and I need to get to grams of zinc because that's what I'm being asked. So grams of zinc in the upper right, and here we go, 65.39. So we got 65.39 grams per mole. Moles of zinc cancel, and when I do this calculation, here's what I get. To 3 significant digits, 12.3 grams of zinc. And that'll do it for number 8. Let's go to number 9. Number 9 says this. It says, how many liters of hydrogen gas will be produced by 5.6 grams of zinc? We're back to this STP. Remember, at STP, all gases have the same volume, 22.4 liters. Let's start by balancing it. This is what's going to balance it. 1, 2, 1, 1 will balance that reaction. And I'm going to start with what I've been given. I was given 5.6 grams of zinc. So I'm going to start there. So I'm going to say 5.6 grams of zinc, just like that. I'm going to put that number over 1. I'm going to convert that to moles immediately, right? So we go to moles immediately. 1 mole of zinc weighs from the periodic table 65.39 grams. This will cancel with this, and I'm left with moles of zinc. But I'm being asked about liters of hydrogen gas. So I'm going to do a mole-to-mole bridge right here. I'm going to go from moles of zinc to moles of hydrogen gas right here. What is that relationship? Zinc to hydrogen gas is a simple 1-to-1 relationship. 1 mole of zinc produces 1 mole of hydrogen gas. It was a necessary step, even though both of those ones are going to cancel away, right? So I'm left with moles of hydrogen gas. I've got one more step now, and what I'm going to do is this. I'm going to put moles of H2 on the bottom, and on the top, I'm going to write liters of H2 because I'm looking for volume. So what's the relationship between moles and liter for H2? Well, H2 is a gas. It's one of the Brinkelhoff elements, and therefore, at STP, its volume is 22.4 liters. So I'll put that right there and cancel this with this, and that's going to allow me to finish this up with liters of hydrogen gas. When I do that, here's the number that I get on my calculator. 1.9, that's liters of H2, and I'm finished with number 9. Okay? One more. Let's look at number 10. All right. Here's what we've got. It says, what volume of 0.5 molar silver nitrate is required to react with 25 liters of 1.5 molar calcium chloride? Now, don't panic, all right? You have to take one step at a time and break it down. What did they give me? They gave me this right here. They gave me these two numbers as the volume and molarity of the calcium chloride. They're asking me what volume of silver nitrate is required to react with that, and they give me the molarity of the silver nitrate, right? So here's what I'm going to do. I'm going to start with what I've been given. I was given the 25 liters of 1.5 molar solution. I'm going to multiply those two together to give me moles of calcium chloride. So now moles of calcium chloride, liters of calcium chloride and liters of calcium chloride are going to cancel, and I'm going to be left with moles of calcium chloride. So 25 liters from here times 1.5 liters, moles per liter from here, that's what molarity means, gives me moles of calcium chloride. Now what I'm going to do is a mole-to-mole bridge because I'm being asked about silver nitrate. So what I'm going to do now is I'm going to cancel this with this, upper left, lower right, and I'm left with moles of silver nitrate. It was a 2-to-1 relationship. 2 moles of silver nitrate reacted with 1 mole of calcium chloride. So here's that relationship right there. So 2-to-1. Now what I'm going to do is I'm going to say, okay, I want volume, however. So I'm going to put moles of silver nitrate up on top, or I had it moles of silver nitrate up on top. So moles of silver nitrate go on bottom. These two are, of course, are going to cancel, but I need volume, so I'm going to put liters of silver nitrate on top. Now, watch what I'm going to do. Kind of clever, I think. Look, molarity is 0.5 moles per liter, but I've got moles on bottom and liters on top. So I'll just put the number 0.50 on the bottom, make that 0.50 on the bottom, and 1 liter on top, and then that allows me to cancel moles with moles, and I'm left with liters of silver nitrate. That's the unit that I want. I'm looking for volume. I'm just going to multiply across the top, divide by 0.50, and when I do, I get 150 liters of a 0.5 molar solution of silver nitrate. Folks, that'll do it for this worksheet. Thank you. Bye-bye.